What we're going to be looking at today is the second part of the alcohols topic, is the types of alcohols and their properties. So what we were doing last day, naming and drawing, was just National 5 revision. Today is when our higher knowledge will start to kick in. So the first thing we're going to look at is different types of alcohols, and there are 3 different types or categories of alcohols. There is primary, secondary, and tertiary. And an alcohol is placed into one of these 3 groups depending on the position of the hydroxyl group. So, primary alcohols have the hydroxyl group attached to a carbon which is attached to one other carbon. So we can see that this hydroxyl group on our molecule to the left is attached to this carbon, which is only attached to one other carbon and 2 hydrogens. So this definition is very important to learn, and you can write this into your booklets. The hydroxyl group is attached to a carbon, which is attached to one other carbon. In a secondary alcohol, the hydroxyl group is attached to a carbon, which is attached to 2 other carbons. So it's not the carbon that the hydroxyl group is attached to, it's what is attached to the carbon that the hydroxyl group is attached to. So the hydroxyl group is attached to a carbon, which is in turn attached to 2 other carbons. And for tertiary alcohols, the hydroxyl group is attached to a carbon, which is attached to 3 other carbons. So for these molecules, the hydroxyl group is attached to a carbon which also has a side chain attached to it. So the hydroxyl group is attached to a carbon which is attached to 3 other carbons. Next, we're going to look at properties of alcohols. Now, we've been looking at properties in Unit 1, for example, boiling point and melting point, solubility and viscosity, and we know that properties are affected by the intermolecular bonds that a molecule exhibits. Now, alcohols have a hydroxyl group, which means they exhibit hydrogen bonding. So, for example, we know from Unit 1 that this group, this bond between your hydrogen and our oxygen is a polar bond, where oxygen is delta negative and hydrogen is delta positive. Delta negative, delta positive. And because that group is very, very electronegative, and the electrons will be lying much closer to the oxygen than they are to the hydrogen, they are put into the very strong intermolecular bonding category, hydrogen bonding. And it means that there will be a force of attraction between the oxygen of one alcohol and the hydrogen of another alcohol. That attraction is our hydrogen bond. And the fact that alcohols can hydrogen bond is what we use to describe the properties of alcohols. The first property we're going to look at is solubility. On the diagram on the left, I have a molecule of ethanol or ethanol. We've got our 2 carbons attached to a hydroxyl group. Now, because this hydroxyl group is very electronegative, it's making the molecule of ethanol very polar. So we have ethanol here, or ethanol, and it is polar. And we also know that it hydrogen bonds. So it will be hydrogen bonding to the water molecules that it is dissolved in. So if you are trying to figure out if ethanol is soluble in water, we know that it absolutely is, because we know that this hydroxyl group, the oxygen is delta negative, the hydrogen is delta positive, and in a water molecule, our oxygen is delta negative and our hydrogen is delta positive. So the positive hydrogen of our alcohol will be hydrogen bonding to the negative oxygen of the water. And because like dissolves like, we know that smaller alcohols will be soluble in water. However, as the alcohols get bigger and their carbon chains get longer, the proportion of polar part of that molecule, the hydroxyl group, to the larger part of the larger non-polar part of the molecule, the big hydrocarbon chain, that starts to become more non-polar. So we find that as the size of an alcohol molecule increases, the molecule becomes more non-polar and its solubility in water decreases. The next property we're going to look at is melting and boiling point. If we were to look at the melting and boiling points of 4 alcohols, so methanol, ethanol, propanol, and butanol, these 4 alcohols are primary alcohols, so we can compare them. The only thing that's changing here is the number of carbons in the chain. And we find that the melting and boiling points of alcohols increase with the size of the hydrocarbon chain. And that is because the intermolecular bonds between those chains become stronger. So alcohols have a higher melting and boiling point than their corresponding alkanes because they can hydrogen bond. So for example, if we're comparing methanol to methane, we know that methanol has hydrogen bonds in between its molecules because it has the hydroxyl group which can hydrogen bond. Methane is made up of just carbons and hydrogens, therefore it's non-polar, it only has LDFs. So methanol will have a much higher boiling point or melting point than methane, sorry. If we are looking at alcohols on their own and we are looking at just increasing the carbon chain of the alcohol, we find that the boiling point increases because the molecule size is increasing, and that increases the strength of the intermolecular forces. The final property we want to look at is viscosity. And viscosity is just a measure of how thick a molecule is. So if you have a very viscous alcohol, it will be one that's very, very difficult to pour if it's a liquid. And if you have a very non-viscous alcohol, it will be one that's dead easy to pour. It will be quite runny, for example. So if we look at the viscosity of the 3 alcohols we've got here, so this one up the top, we've got methanol, butanol, and hexanol. So viscosity increases with the size of the hydrogen chain. So as the hydrogen chain gets longer, so we start off up here with 1 carbon, and then we're getting longer for butanol with 4 carbons, and then 6 carbons for hexanol. Our hexanol would be much more viscous than our methanol. So hexanol would be very viscous in comparison to methanol. So as the size of the hydrocarbon chain increases, the viscosity increases due to the increasing strength of the intermolecular forces.